Yes, good evening, everyone. Am I audible? Okay, okay, thank you. Okay, so without wasting our time, we should start the session now. So today, what we are going to understand, we have to understand what are the various arithmetic operations on binary number. So we have already understood what is binary number. We have studied about number systems. So what operation we can do on binary numbers, we have to understand that, right? So we have studied about the gates, okay? Because before understanding these operations, we should have the idea of all the gates, that what is the output of AND gate, OR gate, XOR gate, right? Then after you can understand these operations very easily. So these are the common guidelines. We will do these arithmetic operations like addition, subtraction, multiplication, division, all the logical operation and representation of binary numbers. So these are the outcomes that you can explain the operation on binary numbers. What is the concept of various operations? Okay, how we can make all these number system and representation of binary numbers. So what is arithmetic and logical operation? Arithmetic operation means like addition, subtraction, we can do multiplication. So if you are given any two numbers, three numbers, and you have to add all these three, two or four numbers, so how we can add that? If I give you two numbers, how can you multiply that? If I give you any number and divide by any particular number, how you can divide that number? Okay, so all these are arithmetic and subtraction also. Okay, all these are arithmetic and logical operation means we have studied logic gates. Okay, so those gate will be known as logical operation like AND operation, OR operation, XOR operation, right? NOT operation. So how we can do these operations? So we should have the ideas of all the gates. Okay, I'll give you the overview before starting that, but you should have at least, right? So what is the basic concept behind all the arithmetic operation? Okay, and before that, you should know what is the normal operation means. You have added two numbers, 2 plus 5, 7, right? Right? This is the decimal addition. But we have studied binary numbers, so we have to do binary addition, binary subtraction, binary multiplication, binary division. Okay, so we have to understand all these in binary form only, means it will be in form of zeros and one. The number will be given in 0 and 1 also, right? Similarly, in case of AND operation or any logical operation, all the numbers will be in 0 and 1 form. So we have studied what is the output of AND, means we have truth tables of all the particular gates. So it should be in our mind that if you have 1 and 0, then what will be the output of AND operation? What will be the output of OR operation? Okay, so that truth table should be in our mind before doing any operation. Okay, so all the numbers will be 0 and 1, and we have studied Boolean algebra also. So that is also useful for all these operations. So let's start with the operations. So these are arithmetic operations. These are right. So arithmetic operations means we will do addition, we will do subtraction, multiplication, and division. And if you are given logical operation, then these are logical operations. So these are AND operation, OR operation, NOT, XOR, right? So any operation can be given, whether it is arithmetic or logical operation. right? Any doubt? Because it is very basic thing. Okay. So before addition, I'll just write something. You can be given either 0 or 1. Okay. So you can be asked to add 0 and 0, 0 and 1, 1 and 0, and 1 plus 1. Okay. So if you add two zeros, the output will be 0. If you add 0 and 1, it will be 1. If you add 1 and 0, it will also 1. But if you are asked to add two ones, means 1 plus 1. So in decimal, it will be 2. In normal decimal addition, it will be 2. 1 plus 1 is 2. But it is binary, not decimal. These one are binary numbers. So this 2 should also be written in binary form. So how can you write it? So we have to understand how can we convert any decimal into binary. So what I told you, you have to divide any number. So this 2 is this 2, and this 2 is for converting into binary. So I am in place of 2, I am taking 3, for example. Okay. So this 3 will be written here, and because we have to convert in binary, so we will divide by 2. So we will divide and write the remainder here. Remainder will be written here like that. So 2 ones are 2, right? Remainder is 1. Again, addition, division. 2, 1 cannot be divided by 2, so it will be divided 0 times, and this 1 will be completely remainder. So we will write from bottom to top. So 1, 1 is the binary of 3, right? So 3 in binary form will be, right? Clear? 3 in decimal, and this is binary. Clear? So similarly, we have to divide here, and this 2 is for conversion. So 2 1 ja 2, 0 remainder, remainder is 0. Again 0 times, this 1 will be written as it is, and we will write from bottom to top. So this is 1, 0, right? So if we add two ones, so there are, in all these cases, there is only one bit. One bit means one number, but here it is 2. So what is the actual sum? So this one is divided into two parts. This is known as sum, and this one is known as carry, right? Like if you add 7 and 6, so 3, this is carry, and this carry will be written as it is a 30. Okay. So similarly, this one is known as carry, this 3 is the sum. So here 0 is sum, 1 is carry. So whenever you add to these numbers 0 0 1 0 0 1 1 1, you have to do like that. So 1 upon 1, so sum is 1, carry is 1, and carry will be written. Suppose here these two numbers are already there. So 1 plus 1, 1 0, plus 0 will be 1 0 again. So 0, this 0 will be written here, and 1 will again carry. So it will be written here. So 100. So this carry will be carry forward to the next step. Okay, it will be added with the next number at the left side, like that. Okay, so this is the addition process, how we can add two numbers. I hope you understood. Any problem? Okay. So here there are two numbers. Any two numbers are given, right? So this is 11 How we can say it is 11? We will write 8, 4, 2, 1. So this is 2 plus 1 plus 8. So it will be 11, right? And this is 13. So you have to add these two numbers, right? So you can see here, this is binary number 1, this is binary number 2. Okay. So we start with the left, right? From this side. So 1 plus 1 will be 1, 0. So this 0 is written here, and this 1 will go in carry. Okay. So we have written in carry block, right? This is 1, this is 0. So 1 plus 0 is 1, and this 1 will be, this carry will be added with this. So 1 plus 1 is 0, 1 carry and will. So this 0 will again be written here, and this 1 will be written in carry, right? Again, so if you have two out of these three numbers, now including carry, there will be 3 bits, two of these two numbers, and this is the carry. So if you have two ones, the answer will be 1, 0. So you write 0 here and 1 in carry. Now you have three ones. So what will happen? So output of the sum of two ones is 1, 0, and third one will be written here. Now you can add it. 1 plus 0, 1, and 1 is 1, 1. So this 1 will be written in sum, and this 1 will be written in carry, right? So if you have three ones, the answer will be 1, 1. So rightmost one will be written as sum, and the left will be written in carry, right? So this is this carry. Now there is no number, no number is there, so this one will be written. So answer will be 1, 1, 0, 0, right? And you write like this. Got it? Any problem? So what is the sum of this? This will be 24. What is this? So we have studied 4-bit, so it will be 16 now. So 1 will be written below 16, second below 8, and 3 zeros below 4, 2, and 1. So 16 plus 8 is 24, right? And this is also 24. Got it? Understood, everyone? It's very easy. Any doubt? Please ask me right now. Any one of you. Prince Sharma, what do you want? Prince, what do you want to ask again? Prince, what were you asking? Because I cannot see the chat every time. Carry, okay. Carry means if we suppose 0, 1, 1, 1, 0, 1. But if two bits are 1, 1, then what will happen? The answer will be 2 in decimal, and in binary 2 is 1, 0. 1 is left side, 0 is right side. So 0 is actually the sum and 1 is the carry. So we will write 0 at the bottom and 1 in the carry. And that carry will be added with the next one or two numbers according to this example that we have written. These are two numbers of binary 1, binary 2 number. And this is the carry. So this carry will be added with these two numbers. Okay. So actually we have to add three numbers. So can you add three numbers at a time? No. You can add two at a time. So you can add either these two. You can add either these two, and what is the resultant will be added with this third number, right? It's up to you. You can add any two numbers, and that addition will be added with the third number. And whatever you are getting, you will get either 1 1 1 0 0 whatever, right? So this is this. So 0 cannot be there because any of the number is 1, then sum will not be 0. Okay, it will be at least 1. Okay, or 1 0. So this 0 will be written here, and this 1, this is carry, is written here, right? Okay, Prince. Okay. So next is subtraction. So again, I will write same number, 0 minus 0, 0 minus 1, 1 minus 0, 1 minus 1. Okay. So 0 minus 0 is 0, 1 minus 0 is 1, 1 minus 1 is 0, but here this 1 is greater. So actually we have to subtract like this. We have to subtract 1 from 0. Is it possible? Can you subtract 3 from 2? It's not possible. So you have to take borrow. So whatever the number is here, we will take borrow from there. Okay. And borrow is always 1. You cannot take borrow 0. That I have taken borrow 0. 0 means nothing. Okay. So you can take borrow 1. So this is subtraction, this is borrow. In this, we have to write like this. Like this. This is sum, right? And this is carry. So in place of writing like this, I will write 0 here at sum side and carry 1. In all these cases, carry was 0 because there was no carry. Carry was in this last case only, 1 plus. So similarly, we will, this S is subtraction, this is borrow. So in all these cases, this is 0, this is 1, this is 2. And in these cases, we have not taken any borrow. But here, you have to take borrow, this borrow. So I have written here, and this has become 1 0. 1 0 is 2, and 2 minus 1 is 1. Okay. So sum is, subtraction is, or you can write difference, D. In place of S, you write D, difference. So difference is 1 and borrow is 1. So borrow is taken only in this case. That is why this is 1, remaining are 0. Okay. Any problem? Because this is the concept that will be used in subtraction. If you don't know this, yes, yes, Minu. So we can take an example. So again, this is binary number 1, this is binary number 2. So you have to subtract it. So 1 minus 1, 1 minus 1 is 0. 0 is here. 0 minus 1. So it is not possible. So we will take borrow, right? So you can see this borrow is written here. And this 0 will become 1 0. And this 1 is this. So 1 0 minus 1 is 1. So this is 1. And this number was 1 and it has given borrow 1. So what will happen? What will be there? What is remaining? It is 0. So it will become 0. 0 minus 0 is 0. And 1 minus 1 is, so this is the answer, 0 0 1 0. So this was number are same that we have used in arithmetic, addition. So 13 minus 11 is 2 in decimal, and this is 0 0 1 0 8 4 2 1. So this is below 2. So this is actually showing 2. So both are same. This is 2. This is also. So it is also verified. We can verify our answer also, that whether we have done correct or wrong, because uh, they may be mistake in taking borrow. Okay. So we have to verify also whether the resultant is correct or not. Understood? Any problem? So addition में carry and borrow. Yes, right. In addition, there will be sum S and carry C. In subtraction, there will be difference D and borrow B. Okay, right. Any problem to anyone? Now multiplication. Should I give you one more example for you? Okay, I am just giving you 1 0. Please give me the answer. 0. Okay. 0 0 1 0. Okay. Got it, Meenal. What about the others? Nobody is doing? 2 3 persons are doing only, right? All are enjoying and rest, taking rest. Yes. Okay. So 1 minus 1 is 0. 1 minus 0 is 1. 0 minus 0 is 0. 1 minus 1. Right? So this is 11, 8, 4, 2, 1. Right? 8 to 10 plus 1, 11. Right? And 1, 0, 0, 1 is 9. So it is 2. And this is also 2. Okay. So both are correct. Hello. Right? So you can verify also that it is 2, it is also 2. It is correct. Any doubt? And if it is 0, 1, 0, 1, 0, 1, 0, 0, 1. What is the answer? Actually, I wanted to give this number actually. Okay, so in this case, we have to take borrow, right? So it will become 1, 0. 1, 0 minus 1 is 1. And this 1 will become 0 after giving the borrow. So 0 minus 0 is 0, 0, 0, 1. Okay. So it is 10 actually, it is 9. 10 minus 9 is 1. It is also 1. Okay. I hope you all have understood. Yes, good. Now the multiplication. What do we do in multiplication? If I ask you 12 into 2 or like this, you have to multiply. What do? You take first number, multiply with all these numbers, right? Like 2 twos are 4, 2 ones are 2, 2 ones are 2. And like this, you write 1 into 2, 2, 1 into 1 is 1, 1 into 1 is 1. And add, right? 4, 4, 3, 1. Okay. So in decimal multiplication, or we can say normal multiplication, we do like that. Okay. But in this case, because it is binary multiplication, so in place of 2, 3, 4, 5, any number, it will be 1 or 0. Okay. So we can multiply like this. So what do? So if we multiply by 0, all numbers will become 0. So we will write all 4 bits 0, right? Now 1, if we multiply any number by 1, it will be same. So we will just leave one place and it will be 1, 1, 0, 1. And we will leave two places. It will be 1, 1, 0. And add all three numbers, right? So 0, 0 plus. Now, in multiplication, you should know means addition also, right? So 1, 0, 1, 0 is 1, 1, 1 is 0, 1 carry, 1, 0, 1 carry, 1, 1. In place of writing here, right here, right? Because carry should be written at the top. 1, 1, 0, 1 carry, and 1, 1, 0, and 1 carry, and we will write, right? So this is the answer. Okay. Now multiply these two numbers. This is first number, this is second number. So please give me the answer. It is already done, but you should do yourself honestly. Yes, whenever we do any operation, it is 1 to 1. 1 bit to second 1 bit, right? So first number is 1, 1, 0, 1, and second number is only 1, 1. Okay. These are additionally written. There is no need, because if you multiply, if there's 1, suppose this one is there, then you can skip it. Okay. But if leftmost is 0, you can skip. Okay. So actually number is 1, 1. So you have to multiply this by 1, 1. So first one will become this, and second number will become, add this, 1, 1, 1, 0, 1 carry, right? 1, sorry, 1, 1, 0, and 1 carry. Okay. What is this number? 1, 2, 4, 8, 16, 32. Okay. So this one is 32. This one is 4. This one is 2. This one is 4. Add all these numbers. 4, 4, 8, 9, 3, 30. So this number is actually 30 in decimal. Meenal, you have all bits 1 and 1 carry. Okay. Do it very carefully because if you change any bit 0, 1 or 1, 0, it is wrong. Be careful. When I carry, I have to put 0, right? When I carry, I have to, yes. Resultant is 0, 1 is carry. Hmm. Sum is 0, 1 is carry. That's why I wrote in tabular form first, in addition and subtraction. Yeah, it's wrong. I wrote also everything this. Okay. I mentioned that this is sum, this is carry. And whenever we write anything, we write sum and carry at the top. Any doubt? Done? Should I give you one more example? Okay. Yes, do it. Done? Should I remove it? Because I have to do here. Writing this decimal number is not required, okay? So you should not waste your time in writing it, okay? This is the main requirement. You have to write this number. So 1 0 0 1 1 0. and multiply by 1011. So for these two ones, I am writing these number directly 10110 100110. For this zero, all bits zero, and for this one, sorry, 0110. Add these numbers. 0, 10 is 1, 11 is 0, 1 carry, 1101 carry, 1101 carry. 3 ones is 11. So this one will be written here and this one will be carry. 11 is 0, 1 carry. This will be 1 and this will be 11010010. Correct. Yes, Meenal, triple one is 1 1. 3. 3 ones is 3 and in binary it is 1 1. I hope you understood the multiplication. Now we come to the division. What do we do? If I ask you 7 or 8 divided by 3, for example. So what do? You start the means table of 3. 3 ones are 3, 3 2 are 6, 3 3 are 9. And 9 is more than 3. So it will be 2 anywhere. Sometimes we write here, sometimes we write here, anything, right? So wherever you have the practice, you can write. I have practiced at the above side, so I will write like this. 3 2 are 6. We will subtract it and we will have 2. So this 2 cannot be divided by 3. So this is the last. So this is the quotient and this is the remainder, right? So same thing will be in binary division. So what is there? Only 1 or 0? Two numbers are there only. So it will be going by 1 or not. Okay. So if it is not possible, we will write 0 there. If it is possible, then it will go by 1 time. Because in this case, we have started the table. But in binary, there is no table. It is 1 or 0. Two numbers are there, right? So what we will do, this is the number that is to be divided by 1. It is not 11. It is 3, right? So what we can do? So we will start this saying means 11 1 1. Okay. So 1 1 is this, sorry, this is 1 1. So we will write 1. It will be 1 1. So it is 0 0. So as per rule, what we do? We write 1, right? We write only 1. We write only next one number. So it is only 1. It is not divisible by 1 1. So what do? We will write 0 and write next 0. So 1 0 is 2. Earlier it was 1. So 1 cannot be divisible by 3. This is 3. So we have written 0 now. And 1 0 is completely 2. 2 is also not divisible by 3. What do? We will write next 0 and write this one also. Right? So what we will do? We will write 1 time and we will write 1. And now what we will do? We will subtract it. 0 and we will take borrow. So it will become 1 0. 1 0 minus 1 is 1. Okay. So this is quotient. This is remainder. So it is actually 29. It is 3. So if you do decimal division, then 3 9 ja 27. It is 2. So this 2 is 1 0. This is remainder. 1 0 1 1 is 9. Okay. And we can verify the answer. Understood? Understood how we have done the division? I take one more example. Okay. 1 0 0 1 1. Okay. We have to divide it by 1 1 for example. So it is actually 19. Okay. It is 19. 3 plus 16 is 19. So we are actually dividing 19 by 3. So please do it and give me the answer. So here when you borrowed 1, it became 1 0. Yes. It is 2, right? And 2 minus 1 is. Yes. Actually, I have just told you that 1 0 is 2, 2 minus 1 is 1. This is just to make you understand. But you should think in binary form also that 1 0 minus 1 is 1. Okay? Think like that. Do this example that I have given you and tell me the answer. So Sanjeet 0 1 1 0. Remainder is 1. Hmm. So what do we do? So we will start with 1. So in 1 we cannot write here because 1 0 is 2. So we have to include 3 numbers. Okay. So we will write 1 1 here. Right. What is this? It is 4 minus 3 is 1. Okay. 1 0 0 is 4. 4 minus 3 is 1. So we will write 1 here. How you can do? You have to take borrow, but here it is already 0. So it will take borrow from here. Okay. And give it to this. So what will happen actually? After giving this 1, it will become 0. This 0 will become 1 0, and this 1 0, from 1 0 it will give 1 to this 0. So this has become 1 0 minus 1, it will be 1. And after giving 1, this 1 0 will become 1. Okay? And 1 minus 1 is 0. And it has already given 1, so it is also. So this is 0 0 1. Understood how I have done? See this. After taking borrow, this I am talking about this 0, right? And this one is this. So 1 0 minus 1 is 1. So answer is 1. And from where this 0 has taken? From the neighbor. But neighbor has already 0. So how it will give you borrow? It will take borrow from next. Okay. So from this one, this borrow was transferred. So this 1 has given borrow to second 0, then it became 1 0, then after it gave 1. And from out of this 1 0, that is actually 2, it has given 1. So what will be remaining here? It will have 1. And 1 minus this 1 will be 0. And this 1 is already given as borrow. So it has nothing. So it will be 0. Got it? Okay. So ultimately we have 1. Okay, 1. Now, as per rule, we will write this 1. Okay, we write down this 1, and 1 1 is directly divisible one time, so it will be. So this is 0 0, and as per rule, we will write 1 here. Now we have nothing remaining after this one. So this is actually the answer, that is 1 1. Okay, is it the answer? It is the answer? No. So it is not divisible, so we will write 0 also here. Like, so this is the answer, and this is 1 is the remainder. So what is this? 4 2 1. So it is 6, and 1 is the remainder. So if you do the same thing here, so 3 6 are 18. So 1 is this, 66 is. Got it? Okay. So I hope you all have understood all the arithmetic operations: addition, subtraction, multiplication, and division. Now we have logical operations. Logical operation means there will be logic behind that, and we have studied all the logic gates, right? So you can give me the answer if you have any bit 0, 1, 1, 0, whatever. So you should know these uh, truth table of all these gates already before doing any logical operation. Okay. So out of this gate has only one input. So we can draw a common truth table for, okay. So we can say A and B are the inputs, and this is the output of AND gate, this is the output of OR gate, this is the output of XOR gate. Okay. Means we will save our energy. Energy means we will write these inputs only once. So 0 0, 0 1, 1 0, and 1. These are the possible combination. I told you how we can write it. This is the formula, that is 2 raised to power n. These are the 2 bits. So n will be 2. So 2 raised to power 2 will be 4. So 4 combinations are possible. If we count from 0, it will go up to 3, 0, 1, 2, and 3. You write these decimal in 2-bit binary number. So 0 0, 1 0, 2 is 1 1, 1 0, and 3 is 1. So these are the combinations that we have written. Okay. First column will be of A, second will be of. Got it? Yes, Meenal, it's correct. What about the third one? Okay, so what we studied in AND gate, that if any number out of 2, any bit is 0, output will be 0. Okay, so you can see in all three cases, out of this is having 0. So all these outputs will be 0 because either one bit or both bits are 0 in these cases. Only last case has 1 1. So output is 1 in this case. And in OR gate, it says that if any bit is 1, any one bit or both bits are 1, then output is 1. So in these three cases, either one bit or both bits are 1. So all these three are 1, and it has both 0 bits, so it is only 0. And what XOR gate says, that if inputs are different, then output is 1. And in these cases, both are same. Either 0 0 or 1 1, both are same. So these are 0 0. And remaining are different. Either 0 1 or 1 0, it will be 1. So this is the common truth table for all these three operations. These three operations. For NOT gate only, because it has only one input. So A and Y is equal to A bar. So 0 or 1, two combinations are there. So 0 will become 1, 1 will become. So this is the truth table of NOT gate. Only one variable, so power 1. Yeah, that's why there are two combinations. And for two combinations, you start from 0, 0, 1. Only two values are possible. Yes, Miriam. Remaining students are also understanding or not? Prasanjit. Okay. So these are the logical operation, bitwise AND operation, OR operation, XOR operation. So you can see here like this. So we will 1 0 1. We will write like this, and final answer will be written here. So this first bit will be AND operation between these first, AND operation will be done between these second, third, fourth. Okay. So at particular position, it will be means operation will be done. So first between first, second with second, third with third, fourth with fourth. So if it is AND operation, so what will happen? So both are one, then it will be one. Both have 0 1, so it will be 0, it will be 0. Both are 1, it will be right. Similarly, for OR operation, what will happen? 1 0 1 1. So for OR operation, what will happen? Any one bit should be 1. So both are 1, it will be 1. Both are 1 is 1 at least. This. So all will be 1. So this is logical OR operation. Okay. So similarly, we can do any operation, right? Same. Any number 1 0 0 1 0 1, right? And 1 1 1 0 0 1, right? So you can do 1 1 1 0 1 1 1. So this is all. Understood? This is XOR operation. So XOR operation says that bits should be different. So if both are different, then it will be 1. And if it's same 0 0 or 1 1, in these two cases, it will be 0. And for not, it is direct. 0 will become 1, 1 will become 0. That's all. So in this case, this 1 will become 0 will become 1, remaining will become 0. Now in binary representation, what do we do? Here, one example is given like this, 6.75. So if you are asked to show this number in binary form, so what we will do? So it has, this is integer part. So integer will be written as it is in 4-bit. So what is this? 8421. So 6 means 1 1. This will become 0. This will be. So for 6, we will write 0110 separately. Decimal will be written as it is. But what do we do with this 0.75? So this is the process that you have to understand. This 0.75 will be multiplied by 2. See carefully. This integer part will be written in 4-bit binary using this. We have written it. We have to convert this 0.75 using this process. So what do? We multiply by 2. So what will 1.5? 1.50 will be the answer. 75 into 2 is 1. Will be written here, and this 0.50 will be, it will be further divided by 2. So what will be the answer? 1.00, right? Again, this 0.00 will be written here, multiplied by 2, and this 1 will be written like this. What will be the answer? 0.00. Why I am writing like this? Because we have to write in 4-bit. Okay. So obviously we have already 0. So finally we will have 0 and 0. So we will just expand up to 4-bit at least. Clear? And what will happen? You might have studied that convert this 9 into binary. What we have done? We divided by 2. In that case, we divided by 2. 2 4s are 8, 1 remainder. 2 2s are 4, 0 remainder. 2 1s are 2, 0 remainder. 2 zeros are, and this one will be written. And we write from bottom to top. It is bottom to top. But in this case, we will write from top to bottom. So after that, the answer of this is actually point, this one, then this one, then these two. So answer of 0.75 means this is this. So 0.6 is already written like this. So that is 0, 1, 1, 0 dot. This value will be written as it is 1, 1, 0, 0. Got it? So this fractional part will be solved using multiplication that will be multiplied by 2. So we will just do it until unless we have 0 or the repeating value. If the same value are repeating, we will stop there on. Okay? Because if we are repeating, it will be repeated for n times, infinite times. So it should not be repeated. You can ask me, sir, at which point we have to stop this process. So until unless we get 0 or or the repetition of the same value. Okay. Okay. Hmm. Yes, 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 Murali. Okay, so I think you have understood all these things very properly. So we will start the next session tomorrow. Okay, we have continuous lectures tomorrow as well as the after tomorrow. So we will meet tomorrow again with the next topic. Thank you so much. Happy learning and attend the next class if you have. Thank you.